Hello, friends. Hope you are all doing well. Today, we are going to discuss the adapter design pattern and how do we implement it. To make it easier to understand, I will first present a problem statement and then demonstrate how we can solve it using the adapter pattern. So, let's dive into it. So, what is adapter design pattern? Adapter design pattern is one type of structural design pattern. It is used to bridge incompatible interfaces, allowing classes to work together without modifying their existing code. It acts as a wrapper that translates one interface into another. What does that mean? Let's understand using a problem statement. So suppose in our system we have different type of payment option available. Like credit, we can pay while placing an order, we can pay via credit card, debit card, GPay or wallet. Okay. So for each type of payment option, we created one particular card. Now we use a third party app to process the payment. So there is an integration. We use that integration to process the payment and we send the information of credit card, debit card or different information in XML format. Now there is some changes happen in the third party app and now they need input in JSON format. For some reason they have done the changes from XML to JSON format. So how to minimize the changes then? Right? Because all our classes are using XML because we have already implemented that one. So how to minimize that changes? Suppose in future they again do some changes in the integration. How to handle that as well? So that is our problem statement. So we have a class called process payment that used to connect with the third party app, the integration present in the process payment class, and credit card called the same class, debit card class called the same process payment, same for GPay and wallet. Now let's see how to mitigate that or how to solve this particular problem using adapter design pattern. So to minimize the changes without affecting all the four classes or so that we can easily support the changes in the future, we can introduce a class called payment process payment adapter, which will talk with, which will connected with process payment and rest of the class that is credit card, debit card, GPay and wallet, all those classes is not going to directly attach with or integrate it with process payment. Rather, they are going to connect it with process payment adapter. And in this process payment adapter, to solve this XML and JSON thing, what we'll do, will keep the credit card, debit card, GPay and wallet classes as is. Will not change anything on those classes. We'll send the XML format that we are previously sending to process payment. Now we will send that XML to process payment adapter. And in that particular process payment adapter, we're going to change the XML from JSON and then will pass it to the process payment so that our third party app will take the input in JSON format. So that is how using process payment adapter, that is adapter design pattern, we can easily solve this problem. So in future, suppose process payment is going to again uh, have introduced something new, we don't need to change anything on credit card, debit card, GPay and wallet classes. Rather, we'll incorporate those changes on process payment adapter. Let's check that in Salesforce Apex class, how we can able to do that one. So let me log in into Salesforce org. So I have already logged in into my Salesforce org, and this is my developer console. So in the developer console, so this is my credit card payment, debit card payment, everything. So here I define an interface, that is iPayment type. So this interface is having one method that is called process payment, and it take the string format as an XML format. Now we use the credit card payment, debit card payment. As of now, I have just created two classes. This implement the iPayment method to maintain the consistency. In process payment, what we are going to do, we get the XML data from client side or from the front end anywhere, and same for the debit card payment. So based upon the card that we are choosing while submitting the order, this will call a particular class. If they are using credit card, it will go to the credit card payment. If they are using debit card payment, then it will come, the request will come to the debit card payment as an XML format. So once this is done, then normally at first when the problem exists, what we'll do, we'll call this payment process in XML. That is nothing but this particular payment process system that we have shown in this particular diagram. So this is the process payment in XML class, and this is what this class is having, that called third party app for payment processing. Now we directly call this class, and same for the debit class, we directly call this one. Now they are changing the XML to JSON. So we created for better understanding, I created a different class, that is process payment in JSON, and I use the like process payment JSON method. Now in this class, if I need to do that one, then what I need to do, I need to change this in XML to JSON, and also in the credit card also I need to change this to process payment XML to JSON. Rather than doing all those things, XML, JSON and all those changes, what I will do, I will not use this direct class in the credit card payment or debit card payment. Okay. Rather, I introduce a adapter class and I will use that adapter class, whereas that particular adapter class will use the process payment. So let me go to the adapter class. This is my adapter class. So this adapter class is also implement this iPayment type. So we need to write this process payment. So in this process adapter payment response JSON adapter, here I have created one instance of JSON so that we can use this process payment JSON. So yeah, I in this particular process payment JSON constructor, I instantiate this payment process in JSON class. And then what I am doing, when I am implementing this process payment that is mentioned in this interface, I am taking the XML format. In everywhere we are using the XML format, right? So I'm passing the XML format, and in this particular class I am changing the XML to JSON format and calling the JSON class, that is this process, payment process in JSON. So rather than changing it in all the classes, what I will do, I will just change the requirement in this process JSON adapter. And as I have used the JSON adapter in this two particular class, I no need to change anything. It will keep on taking the XML format and it will pass to the adapter class. Now it's adapter class responsibility to change it to JSON or some other format, or whether the third party wants it to be sent to an XML format. That is the all the overhead will be in this JSON adapter, and we no need to change 3 or 4 or 6 or different classes. So the overhead or the headache of maintaining the classes will go down. So that is where the adapter pattern is very much helpful when there is two incompatible class or two incompatible interfaces, but we need to make them work together. At that time, in this case, there is one incompatible interface is XML and another incompatible is using JSON. So XML and JSON is not compatible, right? We need to make them compatible. For that one, we use the JSON adapter. So that is how your adapter class will, adapter design pattern will help incompatible interfaces to work together. So that is how you can use adapter pattern. Hope you got the idea where to use this pattern, design pattern. Hope you like this video. If you like this video, please do like, share and subscribe. Thank you for watching this video. Signing off for today. See you in my next video. Thank you.